Okay, so in the first half, we covered how to use the Solar Pathfinder, and we'll do some hands-on with that. And the key there is that the numbers on a monthly basis refer to the percentages. From there, you actually convert it to kilowatt hours and then into savings. So just a little bit of fun math. Okay, so the next thing I want to cover is how to use PV watts. And there's a website out there for doing that, so I'll come right back on that. All right, so here we are with the PV watts calculator, and let's just go ahead and dive through here. So get started. I think it just wants our zip code, 59802. Missoula, that works, okay. So it's got us pinned in there. Let's go to our system info. All right, well, so let's just say let's just do a 2.5 kilowatt system. You can have different module types: standard, premium, thin film. We'll stick with standard for now. Array type, open rack, roof mount, one axis tracking, one axis back tracking, two axis tracking. The back tracking just means that it's going to actually get back to east very early in the morning, but we'll just call it open rack. System losses. Here's a little loss calculator. So soiling, there's some dirt on it. Shading, snow. You can play around with more snow. Mismatch between your. I think the mismatch, that's just between your solar and your inverter type. Wiring, we'll get into line losses later. Connections, there's a little bit of losses every time you connect wires together. Light-induced degradation, so the solar panels over time become less effective, so that number just grows with time. Nameplate rating, that's never perfect. Age, and then, let's see what availability is. Oh. So you shut the thing down from maintenance. So let's say that's fine, like all that. Tilt, 20 degrees, play around with that. And then the azimuth angle, that just means we're pointing the things due south. 180 is due south. Initial economics, fine. Residential, cost of electricity, 9. Good. You can draw it. Or we're just going to go straight to the results. So here's our solar radiation. Kilowatt hours per day, obviously lower in January. It peaks in July, then tapers off. Here are your kilowatt hours, and there are your dollars. It kind of spits back at you what you're after. So from there, there's your 3,000 kilowatt hours per year. You can turn that into a dollar savings. That might be right down here. Okay, so there's your $287. Figure out what the system cost you up front, and then you can just do your payback analysis. So fairly straightforward, the PV watts calculator. So let me just take one quick little break here. So the question is, what's the derating value? It ends up being a percentage. So we actually just talked about that a second ago. System availability, shading, age, etc. Once those are multiplied together, so an age of 1, I mean, it's brand new, there's no efficiency. You can think of each one of these as an efficiency, and you multiply them together, and you get a total system efficiency. So 0.95 times 0.92 times 0.898 connections. Each one of these gives you a little bit of loss. There's some soiling present, the system's off once in a while. So 0.77 is the so-called derating value, the overall derate value. You know, and we can play around with the roof pitch. So that's pretty much all there is to week 3. Oh, we didn't find true south yet, though. There's a little gizmo on there, but the point is that you're usually, you know, within. Actually, we can just go look it up. Let's look up the map. Yeah. Gosh, it's larger than I would have thought. So it might be on the order of 15 degrees off. I remember growing up in Indiana, it was, let's see, there's 10, let's see, 12, 10, 8, 6, 4, 2, 0. Maybe this is 0. Anyway, one of these is 0, and we were very close to true south was magnetic south. But, basically what we're looking at here are the magnetic field lines. You just have to correct for that little bit. So if we're here, your needle is going to be pointing in this direction. So you know you're going to have to turn basically 15 degrees to the east to get to true south, because your compass is always going to be telling you the south is a little bit to the west. That's fairly straightforward too. Yeah, that's it. That's it. And you know, Google SketchUp. I'm not gonna teach SketchUp or Earth in this class, but it's possible to just go to Google Earth. This is exactly what all the solar installers do. They're just going to say, hey, I want to put solar at 8 Columbine Road, Missoula, Montana. Here we go. We click in. We turn and we say, oh man, that's a lot of sun. You can even see a little bit of shading there. But let's turn on Google Earth. Dive in a little tighter. And say, oops, didn't mean to go to Street View. But from here, you can even look at the dimensions. There's 20 feet right there, so copy, paste, put the you know, put your panels up, and away you go. You can even see in this little version, okay, there's a tree there, there's a tree here. Those could cause some shading. Gosh, this is pretty recent. I've just
Probably put it on the garage.
yeah, I've had folks come out and say, yeah, stick that guy on the garage for sure. Probably a flush mount. So that's it. I got to go talk to Tim about actually getting everyone enrolled in the NABCEP exam. That deadline's coming up, so we're going to knock that out and get back to you on that. So that's it for week 3. Little quiz, launch that, and there we go.